Now student, we are going to discuss question number 7.17. Clear? In this question it is given to you, keeping the source frequency equal to resonating frequency of series LCR circuit if the three element L, C and R are arranged in parallel, and then we have to show that the total current in parallel LCR circuit is minimum at this frequency, and we have to obtain the current RMS value in each branch of the circuit for L equal to 5 Henry, C equal to 80 microfarad and R equal to 40 ohm. Clear? And for the AC source of EMF 230 volt. This is 230 volt for this frequency. It is given to you. Clear? So let us try to understand this question. So concentrate on a screen. Clear? Now in this question it is given, we have three elements. Let's suppose we are saying, let's suppose this is L. Clear? This is inductor. I am saying this is capacitor. Clear? And let's suppose this is resistor. All are connected in parallel combination. Clear? And now it is connected with an AC source. Clear? And this AC source is having VRMS. It is given in a question. This is equal to 230 volt. Clear? It is given to you 230 volt. Clear everyone? Yes. Now in this question it is given to you, if the source frequency is equal to resonant frequency of series LCR circuit. Clear? So now we can see value of L, C and R. It is given to you in this question. R value we have 40 ohm. Clear? Value of C we have, this is 80 microfarad. Clear? And what about L? Inductance, it is given to you 5 Henry. Clear? Now we know whenever we are talking about series LCR circuit, so in series LCR circuit at resonance condition, you can see we always find XL, this should be equal to XC, means inductive reactance, this is equal to capacitive reactance. So inductive reactance, it is given by omega L, this should be equal to 1 upon omega C. Clear? So from here we can see this is given by omega square 1 upon LC. Clear? Omega square, this should be equal to 1 upon LC. Clear to everyone? Yes. So now we can see value of omega, this is given by under root of LC. Clear? Omega is given, this is equal to 1 upon under root of LC. Clear to everyone? Yes. So omega is equal to 1 upon under root of LC. Clear? Now this is actually known as resonant frequency. Clear? So from here you can say resonant frequency omega R. Clear? It is given by 1 upon under root of LC. L value is given to you 5 Henry. Clear? This is 5 Henry. And what about we can say C? What about C? C is given to you 80 into 10 to the power minus 6. Clear? So 5 into 80 into 10 to the power minus 6. So we can write like this, omega R, this should be equal to 10 to the power 3 divided by, now we can say 5 multiply 80. 5 multiply 80, this is equal to 400, and if you take square root we can say this is equal to 20. Clear? So now we can say this is given by 1000 divided by 20, and this is equal to 50 radian per second. Clear? This is equal to 50 radian per second. Clear to everyone? Yes. Now we can say this is value of resonant frequency. Clear? Now it is given in this question. Now we have to show if we connect all these elements in a parallel combination, that the total current that we found at this frequency, it is minimum. Yes or no? So how can we find? So for that one, first of all you have to keep one thing in mind. Whenever we have this alternating source in parallel to these elements, potential difference across each element, it remain same. Clear? And you know how can we write? Actually we can write like this. Let's suppose current, this is flowing through this source, this is IS. I can say in this direction current is flowing IR, this is IC, and we can say this is IL. Here you cannot write IS equal to IR plus IL plus IC. Why? Because now you can say in every component there is a phase difference between voltage is to be taking place. Clear? So now how can we write? We can write like this. Concentrate on the screen. Now let's suppose I am taking this direction as a direction of VR, and in this direction we will find this is IR. Clear? In the upward direction we have this is IL, clear, this is IL, and let's suppose I am saying this value we have, this is IC, clear, yes or no? So now let's suppose I am taking that IC is greater than IL, so in this case we can say this is equal to IC minus IL, this is IC minus IL, and I can say this is equal to IR, clear. Now what about resultant? I can say this resultant is given by in this direction, and this should be equal to, we can say this is equal to IS, clear. So we can actually write like this, IS, this should be equal to under root of, we can say IR square plus IC minus IL whole square, yes or no? Yes. So now we can say, we can write like this, let's suppose if we replace all these components by a single component, and you can say that impedance is given by capital Z, clear. So at that time we can say this is, we can say V is the RMS potential, or we can say RMS voltage of source. So we can say this is V divided by Z, this should be equal to under root of, we can say this is V square divided by, clear. Now we can say we have resistance capital R, so this is R square plus this is V minus, we can say this is XC minus V divided by this is XL whole square, clear to everyone. So now we can say if we take V common, we can write this is equal to 1 by Z, this is equal to under root of 1 upon R square plus I can say 1 upon XC minus 1 upon XL whole square, yes or no? Now you can say whenever we are talking about resonant frequency, at resonant frequency you can say XC equal to XL, yes or no? So when XC equal to XL, it means we can say this term becomes 0, yes or no? It means we can say 1 by Z value, this value we are getting, this is equal to only 1 upon R square, clear. So at resonant condition you are getting this term 0. If let's suppose you do not have any resonant condition, at the time definitely you have to add some term with 1 upon R square. It means you are getting minimum value of 1 by Z, yes or no? So actually whenever I am writing like this, I am saying this is minimum value of 1 by Z, and this should be equal to 1 by R, clear. It means I can say maximum value of Z we are getting at this position, that is equal to R, yes or no? In the parallel combination, you are getting maximum value of Z at this resonant frequency, clear. So definitely when we have maximum we can say impedance, at that time we can write, we will find this current minimum, clear, and this minimum current is given by V upon G Z max, clear, and we can say this is equal to R. So I can say this I minimum, it is given by V RMS divided by R, yes or no? So now we can say V RMS, in this question it is given V RMS is equal to 230 volt, so this is equal to 230 divided by, what about R? R value is given 40 ohm, so we can say this is 40, 0 and 0, this one is cancelled out, clear. So I can say this is equal to 5.75, clear. So we can say this is 5.75 ampere, clear. So we can say this is 520, we have 3, so we can say this is 6, 7, correct, and this is 5, clear. So this is I minimum, so I can say minimum current, clear, obtain the current RMS value. So I RMS in this all circuit, or we can say this is value of I, clear, this is value of IS, it is given by 5.75 ampere, clear. But in this question our objective is to find value of current in each component, clear. So we can write this IR is given by, this is V RMS divided by R, clear, this is equal to 230 divided by 40, you are getting same value 5.75 ampere, clear. Now can I find what is value of current in a inductor? Yes, we can write like this, value of IL, clear, value of IL, this is given by V RMS divided by XL, clear. Now what is value of VRMS? VRMS value we are getting, this is 230 divided by what is XL? XL we can say this is equal to omega L, yes or no? So this is equal to omega L, so 230 divided by value of omega you are getting, this is 50, yes or no? You are getting this omega equal to 50, clear, and multiplied with, now value of L is given 5 Henry, so this is equal to 5. So 230 divided by 250, clear, this 0 and 0 is cancelled out, clear. So now if you solve it, you can find 0.9, clear, this is 225. Now we have only we can say this is 2 to 5, we have 5 left, so 0.92 ampere, clear. So this is current that is flowing in a inductor, clear to everyone. Now you can say, now we can find current this is flowing in a capacitor, clear. So now concentrate. Now we are going to discuss how can we find value of current that is flowing in a capacitor, clear. Now we can say value of IC, clear, value of IC, this is given by VRMS divided by, we can say this is XC, clear. So value of VRMS, this is equal to 230 divided by, now what is value of XC? XC is given by 1 upon omega C, clear. So now we can say this is 230 into omega value we have 50, and what about C? C value is given to you 80 microfarad, so 80 into 10 to the power minus 6, clear. So we can see 23 into 100 into 8 into 10 to the power minus 5, clear. So we can see this is 23 into 8, clear, multiply 10 to the power minus 3, clear. Now if you multiply, you can see this is 24, we have 2, and we can say 16, we can say 18, yes or no? Yes. Just a minute. So from here you can see in the calculation 230 multiply 50 into 80 into 10 to the power minus 6, clear. So we can write like this, 23 into 5 into 8 into 10 to the power minus 3, clear. So I can say this is 23 into 40 into 10 to the power minus 3, clear. So now I can write this is equal to 12, we have 1, so 92 into 10 to the power minus 2 ampere, or we can say this is 0.92 ampere, clear to everyone. Now you can say current flowing in a inductor and current flowing in a capacitor is same, clear, and we are also getting value of net current, 5.75, this is same as current that is flowing in a resistor, clear. It means we can say we cannot apply IS equal to IR plus IL plus IC, yes or no? Or now you can say, sir, when all the current is going through resistor, then why, from where we are getting this current? Actually current is flowing in every component, but actually potential that is produced in an inductor and we can say capacitor, they are out of a phase, or we can say they are lying at 180 degree to each other. So actually the net voltage cancel to each other, clear. So now we can say this is all about this question, clear to everyone.